Okay, for people joining this live stream, this is one of our series of meetings of incremental language development for Wolfram Language, in this case, getting ready for things which will be released in the upcoming version of the language. So we are first looking at geo-elevation data.
Right, so this is a continuation of what we saw last week. So, yes. So there are a few notes which are tentative. The first one is something simple. I wanted to explain a bit better what geoid means. So I'm offering these two explanations. The parentheses.
Yeah, I see them. I like the second one.
Okay.
I don't think equipotential has a meaning unless you talk about gravitational.
Right. It requires some knowledge, while the second one is more explicit.
Fine.
Okay, so then you can remove the previous two notes.
Okay. Do we need to look at this?
Then, yes, further down, there are the new...
Stephen, I think you want to remove the other note too.
I can do that later.
Okay.
Yes.
Okay.
So this table contains the new options.
Why isn't center coordinates? I don't understand that. Wasn't that just specified in giving in what you asked geo-elevation data to return?
So the idea is to have the triple georange, geocenter, georange.
Oh, I see. I understand what you're saying, because that's what defines the projection in general. You need a geocenter to define the projection. Is that correct?
Well, geocenter is an alternative way of providing a georange. Given that we are adding georange, it's common to say, I give you the geocenter and assume level, or a geocenter and a range of 10 kilometers.
Okay.
Because that's available in geographics and geoimage, etc. I thought it was a good idea to add them.
Fair enough. That's fine. I assume that we're explaining to people that we're padding out to the bounding rectangle from like a circular center and radius type model.
Yes, that's also what happens in geographics. So I don't think this is explicitly mentioned here, but yeah, it can be added. Yes, so the excluded notes are kind of notes for ourselves. It's there. Yeah.
I think we should say the options, blah, 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 and...
Okay. So there is not a center version of the grid ranges because we don't have a plot center, say. So those are modeled on plot range.
Okay, you seem okay.
Okay.
A lot of subtle issues here. Okay, I mean, I might as well do tentative since I'm here. Okay.
Yep. Okay, so I think it's all clear now.
Does geo-elevation data work on Mars as well?
Yes, of course. So we have data for...
Well, why does it just say for the moon?
Because we added first moon. But yes, we have data for Mars and perhaps for Mercury as well. I don't remember.
Okay. Well, so we should change this note to not just say moon.
Yes, we can add, and the last one also mentioning the zoom ranges. I can extend that to say Mars as well.
Okay. Well, don't forget other planetary bodies. I mean,
Well,
I mean, there's a limited number, right? But
I mean, like moons, other moons, because for Jupiter and Saturn, they are Gauss.
gaseous planets. I
Gaseous,
know.
exactly.
Well, there's Pluto. There's Ganymede. There's all kinds of places. Ceres, all kinds of places.
Right. We have satellite data for some of them. I'm not sure elevation data. I can check with Jeff.
Okay.
Hmm?
I just think we should generalize this and to planetoid or whatever it is, whatever that right-hand side is.
Yeah, planetary moon and minor planet.
Fine, but I mean, geomodel arrow body gives elevation data for a locational region on the moon, Mars, or other. Let me make the change. I think I can do this in a reasonable way.
Yeah.
Okay, so what about something like that?
Yeah, sounds good.
Okay. That should also be dealt with for the other things like geographics and so on, which probably have the same issues. Right?
Yes.
Okay, minor point. Okay, let's keep going.
Yes. So last week we decided to add these 4 pages. So perhaps they are not completely ready for the futurization, but just to have a first look.
That looks sensible.
Mm-hmm. Yeah. So that there's another example with UTM, which is more interesting. So that's used frequently.
Okay.
Yeah. So this allows very fine control of the maps.
Mm-hmm.
Because
that's nice.
Mm-hmm. For example, yeah, geo-resolution.
Okay, so at the North Pole and so on, is there a complexity there or not?
Yes, potentially. For example, if you go down, if you ask for places in which the resolution may be inconvenient, typically what will happen is that you will end up requesting tons of tiles, and then geographics will complain. I mean,
Yes.
if it's doable, if it corresponds to a reasonable zoom, it will be done. Otherwise, it can.
Okay, this is nice. Very nice. Again, geoarray size.
Yes, at the moment, this option is only used by geoelevation data, but it should be extended to
geogravity data, etc.
Exactly.
I mean, there are other things I could imagine this being used on. For example, gridded population data.
Mm-hmm.
And I don't even know. I mean, that's an issue for our spatial. You should point out this option to Roger for the spatial statistics stuff, because I don't even know how we're representing. Do you know how we're representing? In fact, we probably need a function called geodistribution, which gives things like gridded population density.
They are working on spatial point data and similar things, and I have discussed this type of thing with Roger. Here, potentially, we have a similar situation as we had with country data versus entity country, in the sense that eventually we may have so many sources of gridded data that I don't know whether it's better to start slow with separated functions or create some general mechanism.
I understand. That's a very interesting question. I mean, so imagine. So, what are some other examples? I mean, we right.
Think of any, I mean, meteorological, geological property
or astronomical or whatever. Yeah, I mean, the thing is that the gridded case has to be universal in the world, so to speak. So that is saying, I mean, it can be, yeah, it has to be a particular, so to speak. You can't say the gridded form of an elephant is such and such because all elephants are different.
Mhm.
So that restricts the set of things that this can be about. It has to be tied to, presumably, the Earth, for example, or the, or the universe or whatever.
Yes, I think it has to be geographical.
Yeah. Well, so I think it should work through the entity property framework. I think we should basically be able to say of the world, right, that geographics is, I mean, it will be essentially a
Well, it's an
geo
entity.
distribution, right? And then you say what the when once we say right, so then the idea would be what you would do is to say in general for something. So you might say geo distribution. I mean, the idea would be, so geo elevation data. So I would claim the answer is it's geo distribution of population, comma, and then geo region. I claim.
Mm-hmm. Yeah, certainly we need those two arguments, perhaps in the opposite order to imitate entity value, because in this case, the entity is the region.
Well, what would the default be?
And
See, I don't think there's any entity unless you imagine that there's a geo-region construct. I mean, the analog of an entity would be a geo-region.
Yes, we could give their polygons or entities representing polygons.
Well, okay, so but that's going to be a different thing because geo-distribution. Well, okay, this is okay. What's our first example of this? We should get one example, like the gridded population data.
Mm-hmm.
I think Alan has the gridded population data. It would be a terrific thing to try, or the average temperature data or something.
Mm-hmm.
And let's just try putting a few of these in. I mean, maybe that's something for Francisco's team, perhaps, to try putting some in.
Yeah.
And then to try to understand what it looks like, what the interpolation looks like, what the different projections and so on. Super interesting functionality.
Mm-hmm. Indeed.
Okay. All right.
Okay.
Are we on to the next thing?
Yes. So subset map.
Okay. Let me try running subset map for the first time. So, okay, let's see if I know how subset map is supposed to work. Okay, so I say subset map of f, comma. Actually, I can't use f. I've got to say f of hash. What do I actually have to say? I have to say f of hash one.
Use a function that returns a list from a list, like accumulate.
Does it return the same? I'm going to use reverse.
Yeah, it accumulate does return the same length.
Okay, so if I say reverse range of 10, and then I give it 6, 7 here, for example, it'll return 7, 6. Okay, so if I want to make a sorting network, for example, then let's imagine that I do, let's say I say partition range of 10, comma, let's say 2 here, and then I could say subset map. Can I do this? Will that work? If I say subset map of that, comma, this partition thing.
No, a list, no. This is being interpreted as you have a matrix 10 by 10, and you want to act on those elements.
Okay, fine. So how do I get the thing that I'm saying done? Do I have to use fold?
You want to reverse all those pairs.
I want to do this like a quantum circuit or like a So this will be a fold list of this, comma, and then this, right?
Yes. So you can use, for example,
that doesn't look very convincing. What is that 1, 2 doing there? Oh, the fold list.
Subset map of reverse. Oh, you are acting always with reverse. Sorry, on range 10. So you have to put the range 10 on the second argument of fold list. And then say one, yes. So exactly. Right.
Okay.
I think you can also use the operator form of subset map, which would save one of the hashes.
But not both?
Not both. So
okay.
You need to keep the hash 2, but you can remove the hash 1.
And remove the ampersand. No, I can't remove the ampersand. I don't think that's going to work. Because I've got to still have the ampersand there, which means I can't have
yes.
hash 2 be.
Exactly. We cannot mix hashes with operator forms. Right. Sorry. So in this case, you do need the hash.
Okay. All right. Okay. So what are the questions about subset map?
Can you open the documentation?
How do we feel about its name? I'm fairly happy with its name. I mean, I think it's a kind of a complicated concept.
By now, I'm used to it, and I like it, but it's not one of those cases in which you have the truly right name.
Yeah. It's a subset of parts.
Perhaps we can remove the subset off.
Wait a minute. Parts. It's not parts. Oh, yes. In which the elements. I don't think we should say parts here.
Mm-hmm.
In which the elements in the list, to make it less obscure here, in the list E1, E2, for those who aren't reading carefully, so to speak. Whoops. Oh.
Oh, sorry. I've committed this with the wrong kernel. Sorry.
Okay. I don't think that's an unclear description there.
No, it's fine. It's good. The thing I'm missing here is that this function also works on general position specs. So I'm not sure whether that's worth a line in the definition box or just a note.
I think it's worth a line here. What do we want to call it? Pos 1 or?
Yes, we could say pos 1, pos 2.
Actually, what we really want to do is comma dot 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 here.
What?
No, actually, you know what we want to replace? We want to reorder these two definitions. Right, because if we put this one first, then we can then go to the last one. It's just an F dot dot dot.
Right, yeah.
Ugh. Mess. Okay. Okay. Replaces, yeah, elements of expa at positions pos 1, pos 2, dot dot dot. Okay, now this wants to say F of pos 1, pos 2, right?
Yes, or we could say pos spec or something like that. Or, yeah. I mean, as you prefer, we can name the whole thing or the elements.
Okay, now we are going to need to say things about how the posi work and so on. And for goodness sake, give that example with the fold to make people know how they can make their quantum circuits or sorting networks or whatever.
Yes, there are examples further down with fold. Yeah, like this. No, with nest, I used nest.
I think you want to give the sorting network example.
Yeah.
I think you can give a bubble sort or something. I'm not completely sure which one bubble sort is for this, but I think you can give that. I mean, like actually, what you really want is to give something to. Yeah, look. Here's what we want. So what we want is. No, it's actually simply a sort. It's a pairwise sort, right?
Yes, but we would have to choose carefully the list of pairs.
No, you just keep going for a long time, right? So if we just do the let's do this. Here, this is a random integer, 110, like 40,2. Okay. Then I claim, wow, it's really inefficient. I mean, then I guess after, wow, that's really inefficient. Okay, let's try. Well, here, let's just for fun.
Start with something shorter.
Well, yeah, we can also do this. I just want to see it doing its thing. Is this the right thing? Transpose of that, and then list line plot. Am I right? Am I wrong? Yeah, it's doing something. Not sure if this is quite right, but anyway, I'm not sure if this is quite right. I'm going to put this in just as a reminder for you. Okay.
Yeah, I can reconstruct from there.
Okay, I think this is a winner. Any problems here?
The two corner cases, which is, how would you write, before you look at it, how would you write the act on no parts or act on all parts?
Okay, Why do you want that?
Well, they are corner cases that will appear in some situations, so they need to have some syntax. So what's the third argument that returns the list itself and f of the full list?
We have a question on our live stream. Hold on a second about whether something should be legal syntax. Let me just see what is being asked here. So should this be legal syntax as opposed to
partition?
So this is making a nested list there, right? This person is suggesting that the fold be an automatic folding process.
Well, the way this is implemented right now is following extract. Extract will try to do everything at the same time. We'll extract all those parts at the same time and then act on all of them at the same time.
Right. I mean, the truth is, the useful case of this is often going to involve folding. But it's a little bit obscure because what's going to then end up happening is you're going to have to say list/at and then the list of pairs that you do the operation on, and that will end up being the thing that you subset map.
I think fold itself should be used for this operation to avoid overcomplicating the syntax.
Fair enough. Okay, Sandra on our live stream says you have to distinguish a list from folding. Yeah. Yes. No, he's just making the point that the syntax is messy if you try and auto-fold. Okay, so what are you asking? You're asking if one of the elements here was supposed to apply to everything.
Yes. So I'm thinking about corner cases for the third argument, or for example, that case. I have an example for Erlang, which is one of the things I've added recently. I think it's not going to work in what you have, but for example, look at this matrix, the last basic example.
Okay.
And further up.
I'm seeing this nice colored matrix. Oh, scope. Oh, okay, matrix.
Yes, these two examples. So here you see in the first one, you see the standard position spec, a list of positions. So
yes.
A specification of the diagonal. And the other one is saying act on the second column.
As opposed to that being in a double list.
Exactly. We could write 1, 2, 2, 2, 3, 2.
I don't think that syntax as you have it is right. I mean, in other words, I think that syntax as you have it would default to something a little bit crazy that would involve, I mean, I understand that there's no meaningful way in which that could be the equivalent of like 2, 3 or something, meaning just do it in one place.
I don't understand that.
Well, because the simplest case, this case here, right?
Mm-hmm. Yeah.
How do you distinguish this case, which is a very different case, because that case is effectively a list of pairs, right?
Yes, it's effectively a list of pairs, right?
And I think it's slightly obscure that one level list can be both a specific, thing like this, and
yes, it can be also list 2, list 4. It will produce the same output. Recall that the objective here is to have the third argument be in a position spec, exactly like extract, with the exception that a list of numbers represents a list of positions rather than a deep single.
No, I understand that, right. So what's your point?
That all, 2 is accepted by extract. So I think people will expect here that subset map also accepts.
All right. Okay. I don't object to this. What was the next corner case?
Yes, I think in the properties, I have the two corner cases, which is empty list and yeah, the last two examples.
Yes, I agree with that one.
The first one is clearer. The second one is new because that's not accepted by extract. Extract doesn't accept all. But
so what that's doing is it's taking the whole list, applying the operation. That's the equivalent of just construct, accumulate, list.
Exactly.
That's what I would expect it to do.
Mm-hmm. But the point to understand is that this is a new notation motivated by this exception we are introducing of a list of numbers. The previous one is not an exception, is the right thing.
Okay, and why is it an exception again? I mean, what else could this mean?
Try extract of a list, comma, all. No,
it's going to return the list, isn't it?
No, it doesn't work. For some reason, it doesn't work.
Well, I don't think that. I think that's wrong. I think it should just work, which means then it would be consistent.
Mm-hmm. Yeah, if this worked in extract, then I would.
I think it's just a bug that it doesn't work in extract.
Okay. Okay, we will look at that.
Okay, numerator, denominator.
Yeah, that's a simple function, but we need to unfuture.
Did we unfuturize subset map, by the way?
I don't think so.
Are we going to make subset map experimental? I think we should for right now, just in case there's a design problem with it.
Yeah.
What?
That's a joke.
The ARF.
Right.
There's probably some things like that that need to be in there.
Mm-hmm.
Boy, mutate would have been a possible other name for this.
We considered that, but because we are introducing the strand functions at some point.
Yeah.
It might be confusing to.
Yes, that's true.
By strand.
Yeah, by the way, the other alternate names that we thought of, we should look at those as possible keywords here.
Okay.
Yep.
I think I have that list somewhere.
Okay.
And
Numerator.
Stephen, extract works with all if you put all in a list, which is.
Okay. Well, so it probably should work not in a list,
Okay.
which would then make it consistent, I think.
Mm-hmm.
Okay, numerator, denominator. Picks out terms which do not have. Okay. Oh, it's nice that it works on rational numbers, right? That's useful. Okay. I mean, I don't think I need to see this really. Yeah, great. All good. Ordering by guide page.
Yes, we had a discussion and we didn't know where to put it. So we have 3 suggestions here.
Okay. Ordering by. Okay. Which one, what level of obscurity are these various suggestions at, so to speak?
Well, these suggestions are motivated by the presence of either ordering or sort by. So I think these were given in the order of preference.
Where would you put it on this page?
Together with this there. Sort by, ordering by.
All right. Do we need it on other pages as well?
I don't know. It's not very fundamental function. I mean, we need to have it in one. I'm happy with having it here.
Okay, then let's just have it there.
Yeah.
Take largest.
Yes. So here, Danny added the new notation for rules, property rules, which is the second. Yeah.
Why are we putting the list of properties not after all? Can't you say, I mean,
we are following exactly what nearest documented.
Yeah, we're trying to be consistent with that.
okay. I mean, oh, wait a minute. This wants to say, take largest. List our property. I'm sorry, I'm just having a hard time parsing what you wrote here.
Do you mean?
Well, the largest elements.
Right.
Why don't we say the largest elements themselves and the indices of the largest elements?
Okay.
An association giving elements and indices, is that correct?
Yes.
Is that not implemented yet?
I'm surprised by that.
Maybe I've just got the wrong version here. Oh yeah, I've got the wrong version. Magnificent.
Try all.
I see. This isn't right. So Sandra on a live stream is asking, is take largest getting updated to accept a negative second argument so that it switches to take smallest? I believe we discussed this before, and I believe this is not as trivial as one thinks.
That was
because
my
of
recollection.
right, because of ties and so on. I don't think that works to put the negative. I don't remember why, but I believe it doesn't work. Okay, I'm not happy with this element singular.
Yeah, I see what you mean.
Okay, so maybe we should say elements and indices. I think we should say elements and indices.
Oh, there? No. I don't agree. I think it's important to keep the same notation we have in nearest.
All right.
And this is a
okay. All right. Give the actual element.
Perhaps element in the list of largest elements or something like that. I do realize that we need a singular in the explanation.
Yeah. Well, so take largest possible props include give each element itself. Give the index of it for each element.
Mhm. Is it give or gives?
Give an association with index and element. And I think it should be the other way around, unless there's any good reason to have it this way around.
It's perhaps sorted alphabetically.
Okay. Yeah, Sandra is suggesting the transpose of that association list, but I don't think that's right. I think this is the right way around to do it. That each individual thing works this way.
Exactly.
Okay, I'm happy with that.
Mhm.
Okay, last and not least, probably our most controversial discussion of the day. I thought I'd said a little bit more than this, but the idea of this was.
Yes, you had a string there, I think.
Yeah, the possibility of slash, whatever it is, slash user, user local, and then quotes, bin slash bin foo, okay? Turning into, and maybe this is crazy, file of user local bin foo.
Oh. I thought you were talking about structures, accessors of information from the file.
I think maybe I've talked about two different things on two different occasions, which is not a good sign.
Because I would have expected that if we have an object and then we have strings as separate argument, that's a property extraction.
Well, what would let's see, do we have other people here who are relevant to this discussion or not? Because I think this discussion needs other people.
Yes, probably we need Konstantin and Itai for this.
Right, but that's my proposal. And Sushma, I'm going to write that back in there. I mean, I think that was my current proposal, was to use that as a way to, maybe we just should have a function that does that particular thing on a file name, because it seems like that's the thing people always want.
I think Michael said that if we have file, I'm not sure the freedom we have inside file, but if inside file we have something like a file name join with the various parts separated, then perhaps a method string could extract the full thing already joined.
Okay. All right. Well, so that's a detailed thing. Okay. So we need a separate discussion about this.
Yeah. Okay. So now that we know what it is,
right. Well, there's some things that I just sent through to ILD in the last few days that I don't know if they made it onto this list. No. Okay. Well, anyway, good. We finished right on time. So let's just declare victory here. Okay. Thank you, and thanks to everybody on the live stream. And I'm sure we will be doing more meetings. Let's take a look at what tomorrow brings. Oh, we've got yet more database integration, and we've got a graphs and networks discussion for tomorrow. At least that's the current plan. And for Friday, we have some geometric computing. So lots of cool stuff. Wow, we've got one which I doubt we might do as a design of a tension layer for neural nets. That may be too grim to live stream, I'm not sure. All right. Great. Thanks. Talk to you all soon.
Okay,
See you.
bye.
Bye.